So the very first and most important term is aerodynamics. Aerodynamics is a study of how air flow over an object and the force that the air and object exert on each other. Okay, that's whole study on how the interaction between the fluid or air between an object and the fluid. That whole branch of study is known as aerodynamics, and the force on an object that resists its motion through is called drag. Drag is simply the force at opposing the motion. Okay, the resistive force which is opposing the motion of that body, it's simply drag. So the what's the need for a better aerodynamic body? Why it's important? Because the constant need for better economy, greater vehicle performance, reduction in wind noise level. So all these factors, because I won't be able to get the actual output of a machine due to these factors, right? Because these are the negative factors, the one which slow down the actual performance. So I have to make a better design to counteract this effect. So it is important to develop a body, design a vehicle with a better aerodynamic structure, okay, to increase its efficiency. So there are two types of aerodynamic drag. Okay, the one which pulls backward, the opposing. Basically there are two types of aerodynamic drag. One is pressure drag and skin friction drag. So let's look deep into what is pressure drag. So next is pressure drag. It is also known as foam drag. It's a type of aerodynamic drag due to the pressure difference between front and rear of an object moving through a fluid. For example, the body is moving through a fluid, could be air, water, consider an automobile. So it will be moving through air, right? So the fluid will be air. So basically the main cause of this pressure drag, as the name indicate, is simply due to the pressure difference caused at the front and rear of an object. There will be a different type of pressure at the front side, and compared to that there will be different pressure value on the back side. So these two pressure difference cause a backward force to the moving automobile or that object. So this is simply pressure drag is caused due to pressure difference formed at the front and rear part of the body. So this is a representation on an automobile how a pressure drag affect. So as the figure indicates, there will be high pressure zone on the front side and low pressure zone on the outside. So net effect will be drag force, that is high pressure zone and low pressure zone, so that the net motion will be from this high pressure to low pressure, right? So since the body is moving from the opposite motion, it will decrease its efficiency or motion. So what the main cause is due to the main cause of the pressure drag is due to the because the fluid cannot perfectly follow the contour of the object. Okay, different body have different contour structure. So the body, the pressure, the fluid, it could be air or water, it could not follow the prescribed or actual contour of the object, especially if the object is blunt or large, have a large cross section area. So it will oppose the movement compared of the body. So this creates a region of high pressure region, because there is a opposition at the front side of that automobile or any object. So it will not be moving smoothly to the rear side. There will be created a crowded region and region of opposition. So there is a high pressure region developed at the front side, but on the rear side will be having a low pressure, right? So resulting in a net force opposing. This high pressure and low pressure region creates a net movement opposing the movement of the body. So it's the main cause of pressure drag, and the shape dependency mainly due to which type of shape is adopted. So what kind of shape is adopted? The magnitude of pressure drag depends heavily on its shape of the object, right? Streamlined shape like teardrops airfoil, which is the most efficient shape for an aerodynamic, better aerodynamic structure, because these are the best efficient shape, teardrops or airfoil, which reduce the pressure drag by allowing the fluid to flow smoothly around the object. Okay, all other are mostly which cause a drag, but this airfoil and teardrop structure is the most efficient. That's why it's used in the airplanes. So next type of friction is skin friction. So skin friction is also known as viscous drag or friction drag. So this is a type of aerodynamic drag caused by the viscous resistance between the fluid and the surface of an object. So this is directly depends on the fluid property, right? Because why? Because it depends on viscous resistance, which is a property of a fluid. So it simply depend on the viscous resistance between that fluid. It could be air or water and the surface on object. Okay, it's an automobile. It's a depends on the surface of that automobile. So it arises due to shear force that act tangentially to the surface of the object. So skin friction is simply the shear force acting on the surface of the body. There is an air drag. The air is exerting a force on the body of an object. So there will be a shear force along the surface of the body, which causes skin friction. Okay, the term it's a skin of the body is directly affecting the skin of the body and having a shear force. So the cause is skin friction. Drag is a result on the fluid viscosity, which creates a sticking effect between the fluid and object surface. This causes the fluid layer closest to the surface to slow down and create a velocity gradient, right? The fluid layer very close to the surface, I mean just above the surface, will be having a very slow velocity of velocity of air will be very slow. So the air will sustain there, which causes the drag or resistance. This causes the fluid layer closes the surface to slow down, so create a velocity gradient. Like when you move, when the air away from the surface will be having higher velocity. So there's a region of velocity gradient or boundary layer, okay, of varying velocity from the surface of the body. Okay, as move away from the surface of the body, it will be having higher velocity. So this boundary layer or this create main cause. Second one is that same reason boundary layer. So it's a thin layer of fluid near the surface where the velocity changes from zero. I mean at the surface it will be zero, and to the free stream velocity. I mean normal velocity. We know this air is coming with a velocity, right? That's simply the free stream velocity. So as the air above, far away from the surface of the body, will be having the normal velocity of that air, right? But at the surface we will be having a low velocity. That is what this sentence shows. The boundary layer, at the surface it is zero, but as it move away, it's having the same velocity, the actual velocity of that layer which is coming. So the behavior of the boundary layer significantly affect the magnitude of the skin friction drag. The third is surface roughness. It depends on whether the object surface is smooth or rough. So the roughness of an object surface can increase skin friction drag by disrupting the boundary layer. So it has to be smooth. Okay, if it is a rough surface, it will increase the skin friction, which will effectively decrease the that body or that automobile efficiency, or it could slow you down. Okay, these are the main three factors for skin friction. So next term is airflow wake. So airflow wake is simply the turbulent volume of air produced at the rear of the moving car or body. Okay, the turbulent or eddies of air formed at the very back rear side. So this is simply known as airflow wake, and it is has a cross-sectional area equal approximately to that of the rear vertical board panel plus the rearward projected area formed between the air separation and the top edges. So that effective area of that body is what causes the airflow wake. So this is a simple picture of how does an airflow wake look like. Next term is air resistance. This is a very important term for the aerodynamics, air resistance or drag. So force that is exerted on a solid body moving with respect to a fluid. It is due to the movement of the fluid. Okay, so drag is simply a resistance force which is caused by the motion of that body. Whichever is the body, simply the motion of that body is what caused the force or opposing force. So could be either moving in the body could be moving either in a fluid like water or air. So these act opposite to the direction of oncoming flow velocity. We know that body is coming with a velocity. So whatever it is, the drag is simply a force in Newton, force opposing that body, its motion. So it is a relative velocity between. And there is an equation for solving to find drag force, which has a velocity term, and that velocity is a relative velocity between the body and fluid. We know fluid is having velocity, the body is coming with the velocity. Simply the relative velocity between these two is the velocity be substituted to find the drag force. So what is the equation? So this is the equation to find drag force: CD into A into 1 by 2 or 0.5 into rho v square, where v is the velocity of that body. Okay, here in this equation you only have to use velocity. V is the velocity of the body, A is simply the area of cross section, and CD is the drag coefficient. And drag coefficient varies with the different body. It's based on the structure of the body. there is a constant value, and d is simply drag force, and rho is the density of that medium, air or fluid, whatever that fluid is. And next is drag coefficient. Drag coefficient is denoted by symbol CD, and is simply a dimensionless quantity that represents the amount of drag or resistance experienced by an object moving through a fluid. So the magnitude or the value will indicate how much a body will experience drag, and it varies with the different structures. So it's a measure of object shape and size, as well as the fluid viscosity and density. So simply that value indicate how much an object is experiencing drag. So it's simply a dimensional quantity, dimensionless quantity, which indicates how much a drag effect.